how we would figure out this area to the right of 1.11. We do technically have enough information to figure it out. We just have to use some clever tricks. So does anyone have any ideas on how we would deduce that? So here's a hint. All of the area to the right of the axis is 0.5. Remember that. So what you could do is take all of the area, which is this right here. So all of the area to the right of the axis, 0.5. And you could subtract the area that you're able to look up, which is this area right here, right? So if you take 0.5 and subtract that area that you're able to look up, it'll give you the remaining area, which is the area to the right of 1.11. So that is how you would figure out what is the area to the right of 1.11. You basically take the entire chunk of area, you subtract the area that you don't want, which is the one that you can look up, and it gives you the remaining area that you do want. You can kind of
John,
picture.
sorry.
Go ahead.
How did you get 1.11? Like, how did you get to that number?
Oh, that number is that was just an example. Yeah, just a random value. Just for illustration.
Oh, man.
Is he here?
Yeah, so when we do the actual full questions, then I'll show you how to get to the particular Z values. This was just for illustration. Yeah, so don't worry about the 1.11 part too much. So in this case, another way of looking at this is, you know that this length, you could think of it in terms of lengths if you want. You know that this length right here, the length of the whole right side of the curve is 0.5. You know what this length is because you're able to look it up. So if you take the bigger length and you subtract the smaller length, you get what's left over, which in this case is what you actually wanted. So that's just an example of sometimes you have to use tricks in order to figure out what it's asking. So that's an overview of the normal curve. So now let's start on the actual question that we were doing. So I'll just get rid of this. Okay, so let's so this question was pretty much the same as 1B, except we just picked a slightly different value. So the X bar is 114,000. So we have to figure out the Z score for that. So let's do 114,000 minus the mu, the average, which is 110,000, divided by sigma, which is 40,000, over the square root of n, which is 50, so square root of 50. And then you just put this in your calculator. What I would do is I would do the top part first, 114,000 minus 110,000 is 4,000. And then divide that by 40,000 over the square root of 50. So for this part, I would take 4,000, hit divide. To be safe, I would hit bracket and then just do the bottom part. So do 40,000. Sorry, one sec, I just messed it up. So so do 40,000 divided by square root 50 and your bracket and hit equals.
Is it going to be automatic?
And you should get, in this case, it's 0.71 rounded. So everyone try that on their calculator and make sure that you get
I don't know.
the correct value. Try not to put in the entire thing in your calculator, because if you put this whole thing in and you forget to hit equals on the top, you won't get the right answer. That's why I always take a second to figure out the actual top value and figure out what that is, and then divide by the bottom, so you don't have to worry about that. So 4,000 divided by all the bottom stuff, you get 0.71. So hopefully everyone got that same Z score. So that right there is your Z score for this question. And let's reread the question. What is the likelihood of selecting a sample mean above that? So let's draw this. So we have to figure out the area of...
John?
Yeah.
Sorry. The getting to 0.71, how would you punch in square root 50 on a calculator to be able to determine that?
Oh, sure. So just use the square root button. So it should look like this. So go on your calculator right now, and we'll do this together. So let's start at the top. 4,000, right? Hit divide, and now we're going to put in the bottom part. So just to be safe, let's put in a bracket. Just enclose the entire bottom part with brackets, and then type in 40,000, and then hit divide, and then go find your square root button. So it should look again just like this. So hit square root, and then hit 50, and then end your bracket, and then hit equals. So did that work?
Yeah, I'm seeing 0.707.
Perfect. Yeah, I just rounded it because these are always rounded to 2 decimal places. But yeah, the original, it's 0.7071.
I just wanted to find out how to write that in there into the calculator.
Yeah, so that's how you do it. And then there's other ways of doing it as well. Like you could figure out the actual bottom number. You could do 40,000 divided by square root 50. Could it equals, and then you could just always use that number. That number is 5656.854249. So you could always just do top number divided by this, and you could do that way if you want as well. It'll give you the same answer. I prefer just doing 40,000 divided by square root of 50, because then you'll get the most accurate answer. Okay, I'm just going to erase that part just so people don't get confused about where that number came from. Okay, so we got 0.71, and you have to read the question. It says above that number, so we need all the area above 0.71. So let's draw our curve. So it wants everything to the right of 0.71. 0.71 should be about right here, because remember it goes 1, 2, 3 spaced out over the entire thing. So I'll just put it right here so you can see it easily. So 0.71, and it wants everything above that. So it wants this. So how do we figure that out? Again, if you just look up 0.71 in the table and you just use that, it will not be correct, because that will not give you the shaded area. It will only give you this part with the question mark in it, because that's just how the chart is designed. It only just does between 0 and the z-score. So this is one where we have to use some trickery. So we're kind of stuck in a scenario where we want the shaded part, but we're only able to look up the question marked part. So what you do is you take the entire area on the right side of the curve, which remember is always it's always half the area, so it's always 0.5. So you always take 0.5 and you subtract the question marked area that you can actually look up, and that will give you the leftover area, which is the actual shaded part that you want. So sometimes you have to subtract what you are able to look up that you don't want in order to get what you actually want that you aren't able to directly look up. So 0.5 minus, so let's look up 0.71 in the chart. So go to 0.7 and then go to 0.01, and it's 2611. So do 0.5 minus 0.2611. And that is, it is 0.2389. So that is your answer in this case. So the shaded part is 0.2389 or 23.89%. Yeah, and let me try to, for further illustration, let me try to draw that with all of these values included in the curve. Try to draw a larger curve. So yeah, so the entire area on the right here, I'll just draw it as a length like this, is 0.5. So that's everything to the right of the axis. And then what you wanted was, you wanted to look up, let's say the z-score is right here, you wanted everything to the right of that. But you were only able to find this part right here. So you just subtract the longest length and you subtract that from the shortest length, and you'll get that mid-length that you want. So again, I just personally find it useful to think of it in terms of length, because then you can see the logic geometrically of what you're doing. So that's what you do in this case. So each of these cases is basically like that, where you figure out the z-score, and then you have to look at the question, figure out what area it wants, and then you have to use some trickery in order to figure out what area it is. Sometimes you might just be able to look it up directly in the chart, but sometimes you might not be able to. It just depends on what it's asking for. But
John,
the best way is always, yeah, go ahead.
Sorry, did you say subtract the larger portion and then the shorter portion, or you use the larger portion to subtract the smaller portion?
So it would be this one right here, which is all of the area on the right, and then it would be minus this area that you're able to look up. And then the result would be the area that you want, which would be this area right here.
Okay.
Yeah, sorry if I didn't draw that super well.
And you also said to use the chart. On the chart, we're looking for the 0.5 and the small portion number?
In this case, you would use, so 0.5 you already have, just because you know that all the area to the right of that is 0.5. So what you would do is 0.5 minus, and then you would look up the z-score for 0.71. So you would look that up, and that is 0.2611. And then you do 0.5 minus that, and that will give you the actual area that you want. Yeah, okay. If you look at the curve that has the question mark, you see that?
Mm-hmm.
So what you're doing is the 0.5 is that entire curve on the right side.
Right.
And then when you subtract 0.2611, you're basically getting rid of the question mark area. Oh. And when you do that, you get the remaining area, which is the one that we want.
Okay, so what two numbers did you say is on the chart?
For the
0.71?
Yeah, so you look up 0.71, and that will give you the area for where the question mark is. So that's 0.2611.
Okay.
Yeah, that's the only part that you have to look up in the chart for this one.
Okay, thanks.
Yeah. Okay, now let's go. So that was the first question. Kind of the first question, a little bit different. Now let's keep going through them, and we'll see what other tricks we have to use for the next one. So let's see. Let's clear this, and let's reestablish all the information. It's all the same. So mu is 110,000. Sigma 40,000. N is 50, and I guess that's everything. So let's do one. So we did B. Let's do C, or a slightly altered version of C. So what is the likelihood of selecting a sample mean above 100,000? Okay, so let's do. Why don't we pick? Let's do 102,000, just to do a similar example. So let's say X bar equals 102,000. Okay, so same thing. Use your fancy z-score formula. Z equals X bar minus the average divided by sigma over the square root of n. So everything is the same in this case, just now the X bar is 102,000. So for this entire question, sigma is always the same, mu is always the same, and n is always the same. The only thing you're changing is just the sample average. Okay, so X bar, 102,000, minus mu is 110,000, divided by 40,000 over square root of 50. So as per usual, let's do the top first and figure out what the actual number is. Because if you do 102,000 minus 110,000 divided by the bottom, it'll give you the wrong answer, because it'll think that the bottom is only part. It'll think that only 110,000 should be divided by the bottom, when in reality it's the entire top divided by the bottom. So in this case, take a second to get the actual number on the top. So 102,000 minus 110,000 is minus 8,000. Good. So minus 8,000 divided by 40,000 over square root 50. And there's also something important to note in this case. Whenever x bar is more than the average, your z-score will be positive. Whenever x bar is below the average, your z-score will be negative. And that's just the way it is. So in this case, you should expect a negative z-score. So if you get a negative z-score between 0 and minus 3, you'll know that your z-score is reasonable, because they always fall between like minus 3 and 3. So go on your calculator, type in minus 8,000, hit divide, and then again, let's put some brackets in there just to be safe. So bracket 40,000 divide square root 50, and your bracket, hit equals, and you get a reasonable answer. You get minus 1.414, and just round it to 2 decimal places because the chart goes to 2. So let's round it to minus 1.41. So that is your z-score. So let's just put z equals minus 1.41. Okay, so there's your z-score, and let's read the original question. What is the likelihood of selecting a sample average above that? Okay, so it wants all the area to the right of that. So let's draw that. And it's a little different from the previous scenario because it's a negative z-score, so it's on the left of the curve. So that's why it's really important to always just draw the scenario, because there's always little differences. Okay, so where is minus 1.41? Let's say it's around right here. Minus 1.41. Yeah, right there. And let's do this. And we need all the area to the right of that. So we need this area right here and this area right here. So a lot of area, like your answer will clearly be more than 0.5. Okay, so how do we figure out all of that area? Let's do this one step at a time. All this area on the right, to the right of the axis, is going to be half. It's always half the area on the right. So that part is going to be 0.5. So you don't have to look that up in the chart. You just have to remember that it's 50-50. 50 to the right and 50 to the left. So that part's good. So we know that's 0.5. The next part we have to figure out is the remaining part right here. Now, you might notice that on your chart, there are no negative z-scores because the curve is symmetric. So there's no point in having 2 charts because they would be the same for positive and for negative z-scores. So since you can't directly look up minus 1.41, what you'll have to do is you'll have to look up positive 1.41. And that will give you the appropriate area right there. Because, and let me just draw a separate one for this. Yeah, because in this case, you want that area between